Hello everyone from Quebec City, Canada. My name is Stéphane Couture and I work as a Global Product Support Specialist with Olympus NDT. In today's video, I would like to present you our line of HTHA phase array probe and compare them with a regular 5 MHz A31 phase array probe. To do so, I will be using a sample with some nasty blisters in it that also has other indications that can or cannot be HTHA. They certainly look like it. So we'll be reviewing phase array as well as TFM. All the probes I will be using today are fitted with a 0-degree wedge. So starting off with the regular 5L32A31 probe, that is our go-round weld inspection probe. So if I position it on the sample, we can see the back wall, can see the blister, and in between we have a lot of small rounded indications. We can certainly detect it. The resolution is good enough, but I think we can improve it. So if I remove the 5L32 and move on to 10 MHz 64 element instead. Now, if I position it in the same spot, I still have my back wall, blister, and now I'm able to detect with much better resolution everything that's in between. All this cluster or colony that is in between is much better resolved. Even close to the blister, we can still see it. Now changing to the 10 MHz dual linear probe, or 828 dual linear probe, again fitted with a 0-degree wedge. Moving on to the same spot once again. And still, we are further improving on the signal we had. Now we can actually see the different facets of this crack blister indication in there. So probe technology can help with resolving your inspection. Also, switching technology altogether can also help. So testing with from phase array to TFM using the 5L32A31 to give us a baseline. So as I was mentioning, 5L32A31, that's the standard probe. It is fitted with a 0-degree wedge. Today I'm using, for phase array actually, I'm using a negative 30 degrees to positive 30 degrees. In this particular sample, I find that it works best, but your own sample, your own material may provide different results. In this case, with TFM, we are doing LL wave set. And as you can see, we improve over the phased array with the same probe, obviously. But comparing it to the 828 or even the 10 megahertz A31, I don't think there's much improvement there. So switching to 10 megahertz, 10L64A31, and let's see what kind of result we can expect with this probe. Again, same casing, same 0-degree wedge. The only difference is that it's 10 megahertz and 64 element. So higher frequency, obviously, but also because the OmniScan X3 can take advantage of the full 64 element aperture for TFM, we also have 64 element TFM compared to 32, which should also help with the resolution. And as we can see from the get-go, this is exactly what's happening. Much, much better resolution than with the 5 megahertz one. Looking at the end view as well as the scrolling B-scan. Can increase the gain a little bit. Now everything becomes crystal clear. So if you would like more info on those probes, you can always contact us or your local sales representative. All of the info can also be found on our website at olympus-ims.com. Thank you for joining us today. Have a great day.